Hello everyone, welcome to Quantology. So this is our very first video on this channel, and from this onwards we are making a new beginning in which we are going to provide the classes for the quantitative aptitude for the CAT 2024 examination. To start the things in the best possible way, I have decided that we'll be starting with the previous year question paper, and that is the recent one that has been happened in November 2023. So this is a question paper, or we can say questions from the slot 1 of the CAT 2023 examination. So in this video we will be discussing only 5 questions, and later on in the upcoming videos we will be discussing another 5 questions. So in this way we are going to complete the questions in the slot wise manner. So let us start the new beginning with new enthusiasm. Okay, so this is the first question that has been asked in the CAT 2023 examination. So according to the question, x and y are the real numbers. So there are two numbers x and y, they are the real numbers, and a equation is given to us and we have to find the value of x minus 2y. It is a very simple question from the algebra, we can say. So if I try to just rearrange the equation, x square plus x minus 2y minus 1 whole square, and taking the things or the right hand side to the left hand term, so we will be having plus 4y, or we can say 4xy plus 4y square, it is going to be 0, right? So if we consider these three terms, so these are making x plus 2y whole square, right? X square plus 4y square plus 4xy plus x minus 2y minus 1 whole square, it is 0. So it is one of the important thing that you should consider, or you should think, that square of two terms can only be 0, that is a square plus b square. If it is 0, then it is the only possible case when both a and b are actually 0. So here I can say x plus 2y should be equals to 0, or x minus 2y minus 1 should be equals to 0. So again it is saying we have to find the value of x minus 2y. So it is nothing but x minus 2y, it is coming out to be 1. So which is given in the option number 1 itself. So hopefully this question is clear to you. Moving to the next question. Okay, question number second. It is a number system question, and it is saying n be the least positive integer such that 168 is a factor of 1134. So if I want to know the factor for number 4, if I talk about the 4, so 4 is a factor of 8 also, 4 is a factor of 16 also, means for a number to be factor, it should actually divide the given number completely, leaving the remainder 0. That is a proper definition of the factor. So if I am saying 1134 power n is divided by 168, remainder should be 0. If remainder is 0, then I can say that 168 is a factor of given number. Okay, so if I want to do the prime factorization, right? So 1137 or 1134 can be written as 2 into 56 567. Again it can be written as 2 into 81. Sorry, this is 7 8s. I divided by 7, so 7 8 81. Then again 7. So I can say 2 into 7 into 3 power 4. So it is 1134, no problem. If I talk about 168, so 168 can be broken as that is 2 into we can say this is going to be 4 4 is 16, 42. Again 2 into 42 can be split it as 2 3 then 7. So this is going to be 2 power 3 and 7. So hopefully this prime factorization is clear to you. Now if I talk about the solution, so it is saying that 1134 raised to power n divided by 168. So if 168 is the factor of this number, then it should leave remainder 0. So if I just write it in the prime factorization form, so this is coming out to be 2 into 7 into 3 power 4 complete power n divided by 2 power 3 into 7. So we have to find the least value of n actually. So this is possible 2 power n into 7 power n into 3 power 4n divided by 2 power 3 into 3 into 7. So if I want this remainder should be 0, so you should be very clear that at least n must be 3. For n equals to 3, this complete number is divisible by 168. Hopefully it is clear. So I can say least value of n is 3. Because if n is 1 or 2, then we cannot divide 2 by 2 ki power 3. We cannot divide. So that's why n has to be 3, right? So we got the least value of n, that is 3. Now if we talk about further, if n is the least positive integer such that 1134 power n is a factor of 168m. Now we have just we can say reciprocal the number. Now what is going to happen? Okay, so let us see once again. It is saying that 168 power m and it is 1134 power n. Now again 1134 power n is a factor, it means it should leave the remainder 0. So again I can split, or I can write this in the prime factorization form, 2 power 3 into 3 into 7 power m. Now here I have already I got the value of n as 3. So this is going to be 2 into 7 into 3 power 4 power 3. So here it is 2 power 3m into 3 power m into 7 power m divided by 2 power 3 into 7 power 3 into 3 power 12. So least value of m should be, here we have 3 power 12 and here we have 3 power m. So can you tell me what should be the least value of m? Of course it should be 12. Then only I can say this complete number is divisible by 1134 power n, right? So I can say least value of m should be 12. So by addition of m plus n we will be getting our answer. So it is asking for m plus n. So this is going to be 15. So hopefully this question is very clear to you. Moving to the next question. Again, x and y are the positive real number and this question belongs to logarithm function. So there are some properties which actually you should know to solve this question actually. So it is saying log with base x square plus 12 equals to 4 and thrice of log base y x is 1, and we have to find the value of x plus y. So if I go with that, if I want to remove the log, so x will be going in the right hand side in the base of the 4. So I can write x square plus 12 should be equals to x power 4, right? Similarly, if I remove this value, I can say this number can be written as log base y x cube equals to 1. If I remove this log, so I can say x cube should be equals to y. So I have two relations, and from these two relations I have to find the value of x plus y. Now if I solve this number, let x square equals to t to make a quadratic. So this is t plus 12 equals to t square. So t square minus 12t minus t equals to 0. So I have t minus 4 and t minus 3 equals to 0. So I have t equals to 3 or t equals to 4. I have the number t equals to 3 and t equals to 4. So what is t here? Actually x square. So x square is 3, or I can say x square is 4. So if x square is 4 actually, so I can say x can take to value plus 2 or minus 2. But here I cannot take x equals to minus 2. Why so? Because base of the log cannot be negative. It is always positive. So I will be eliminating the value x equals to minus 2. So we are left with x equals to 2 from here. Okay, x square equals to 3. X square equals to 3. Okay, x square equals to 3. So suppose now we are in the position, we will be solving the answer. So we have a equation x cube equals to y. X cube equals to y. So if I take x equals to 2, so 2 power 3 should be equals to y, then y should be equals to 8. So we have the value x equals to 2, then y equals to 8. If I take x square equals to 3, then x would be equals to root 3. Or what would be the value of x cube equals to y? So it would be 3 root 3. How come it is 3 root 3? Because I have to x equals to root 3 and I have to cube it actually. So this is y. So y should be equals to 3 root 3. Y should be equals to 3 root 3. So it is asking that which of the following is a. Now according to the option, if I add 2 plus 8, this is going to be 10. Because if I add root 3 and 3 root 3, I will be not getting any of the options. So according to this, the answer should be 2 plus 8, that is 3. So hopefully this question is also clear to you. And if I want to know if there are any restrictions on y, I cannot put yes, it can be the right answer. Yeah, it is possible. It is also possible, but in this question we have to just go by the options also. So this is going to be 2 plus 8, that is equals to 3. Okay, so moving to the next question. Again, we have to find the number of integer solutions of the equation, right? We have to find the integer solutions of the given question. So it is saying twice of mod x square plus 1 equals to 5x square. So we have to find the number of integer solutions. So here we have mod x. So mod x can be written as x and minus x if x is greater than equals to 0 and x is less than 0. Okay, so these are the possible cases and when we are expanding the mode actually. So if I taking the positive, so this is going to be 2x into x square plus 1, this is going to be 5x square. So if I just writing it 2x cube plus 2x minus 5x square equals to 0. So taking the x common, so we are left with the 2x square minus ka 5x plus 2 equals to 0. So from here I can say x into, this is 2 to 4, so 2x square minus ka 4x minus ka x plus ka 2 equals to 0. So x, and this is going to be 2x common, so x minus 2 minus 1 common, x minus 2 equals to 0. So x into 2x minus 1 and x minus 2 equals to 0. So from here I have the value x equals to 0, x equals to 1 by 2 and x equals to 2. So we have 3 solutions possible. Now if I take x minus negative of x, means there should be negative value of x. So let us see whether we will be getting negative value of x or not. Okay, so let us see this also. So I have kept that aside. Now we will be solving next part, that is when x is negative. When x is negative, so what would be our answer or what would be the consequences? So I will be writing twice of minus x, then x square plus 1 equals to 5x square. So now this time I will be multiplying once again. So we are left with minus ka 2x cube minus ka 2x minus 5x square equals to 0. No problem. Taking minus x common, so again we are left with 2x square minus ka 5x, sorry, plus ka 5x minus ka plus ka 2. So this is going to be 0. So minus x, so this is going to be 2x square plus ka 4x plus ka x plus ka 2 equals to 0. So minus x, this is going to be 2x common, so x plus 2 plus ka 1 x plus 2 equals to 0. So from here minus x into 2x plus 1 and x plus 2 equals to 0. So x can be 0, x can be minus half and x can be minus 3. Right, so we have to find for how many integer solutions. So it is asking for the integer solutions that I get. So here 2 is an integer, 0 we can say, again 0 we can say, and again minus 3. So how many solutions do we have? X equals to 0, x equals to 2 and x equals to minus 3, because here all the x are negative and we must get x equals as in 0. So our both conditions are satisfied actually. So our answer would be 3. Answer is going to be 3. So it is given, possible answer is 3. So hopefully this question is also clear. Now moving to the last question of the today's video, and it is saying root of 5x plus 9 plus root of 5x minus 9, it is going to be 3 to just 6 plus 3 root 2. So if I could have used mathematics here, then I could have gone actually. We should have think we are adding two numbers and our result is one rational number and one irrational number. Means out of these two numbers, one should be rational and one should be irrational. Are you getting this? So this is the main punch of the question. So if I solve the question, so if I take which is the number of x, so that can make actually rational. So if I want to say, let assume 5x root 5x plus 9 should be equals to 6. So from here 5x plus 9 should be equals to 36, squaring both sides. So 5x should have been equals to 27, then x should have been 27 upon 5. If it is true value, then it should satisfy this also. So let us solve this. So root 5x minus 9, I should get 3 root 2. So 5 into 27 upon 5 minus 9. So this is going to be root 18, which is nothing but 3 root 2. So of course this is the right value of x. So I got x equals to 27 upon 5 is the solution of the given equation. Now we have to find the value of root 10x plus 9. Very easy now, root 10x plus 9. So 10 into, this is going to be 27 upon 5 plus 9. So 5 to the 20, so this is going to be 63. So and 63 can be written as 3 root 7. So option number 3 is given. So that's all for today. In 18 minutes we have done 5 questions, and in the next video we will be bringing another 5 questions from the slot 3 of the CAT 2023 examination. So see you in the next video. Till then, you please subscribe the channel Quantology for the quantitative aptitude for the CAT 2024 examination. So see you in the next video. Bye.